Hello, everybody. My name is Brian Douglas, and I'm going to talk to you about getting traction with GitHub Actions, specifically continuous delivery with GitHub Actions. So today I'm going to focus on continuous delivery, but I'm also going to add in a couple different ways you can implement custom logic with GitHub Actions. GitHub Actions is a way to interact with your GitHub repositories in addition to do continuous integration as well as continuous delivery of your projects. Now, if you weren't aware, if you go into your GitHub repository, you'll notice there's an action link directly above in your menu bar. And there you'll get introduced to different action starter workflows. Now, this is an example of me using JavaScript, so it's going to recommend me JavaScript action workflows. And they're going to look like this. It's going to be based on YAML. So if you're familiar with things like Azure pipelines, you'll be familiar with this syntax, as well as the opportunity to run actions on specific GitHub branches. Here, I'm actually running a CI workflow that runs on 4 different versions of Node.js. Shout out to 10.x, which is just recently end of life, or into supported actually. And I'm using a couple different actions, but this is only one concept of using GitHub Actions, which is CI. I think that CI and CD is like they come together, and it's, once you have your DevOps plan orchestrated in a way that it just works, it kind of looks like this. And this is a GIF of obviously a smart DevOps engineer who's really focused on just getting the job done where it needs to get done. So opportunity for optimizing workflows and finding a place where you can improve that. Now, me personally, I like using this action called the Lighthouse Action. It's created by GitHub user Jake Jarvis. And what it does, it gives you a Lighthouse score at the time of a PR. Another great example of a GitHub action is my continuous delivery action, which is automating my Storybook deployments. Now, Storybook.js is a design system builder to give you the ability to, well, just do that, which is build a design system. And my design system looks like this. And I'll go into this in way more detail at the end of this talk, as well as the Lighthouse action. But what I wanted to do up front is give you some real concrete examples of how I'm using GitHub Actions. Now, I've said GitHub a lot. I should probably also mention GitHub, subsidiary of Microsoft. It's a collaboration platform, for developers, for product managers, for designers to all collaborate around your code base. This has really come in handy in the last year and a half because GitHub really focuses on collaboration at scale. Collaboration at scale is a really strong piece of what GitHub succeeds at. And I say all that because I work at GitHub. I'm a developer advocate at GitHub, and my name is Brian Douglas. Those are my handles, bdougio and bdougie on GitHub. And I mentioned that because this is my GitHub profile. That's exactly what I look like on the internet. And I'm actually using a GitHub action to recreate MySpace on my GitHub profile page. This is a fun little hack I did last summer when we shipped this new feature called the GitHub Profile Readme. And the way this works is that every issue that someone opens up in my repository, adding their name to my list of developers that I'm friends with, it gets added to my top 8. And this is my top 8 as of today. Now, GitHub Actions was something that was shipped back in 2018. And it was really just a way for GitHub to give you all the primitives of GitHub out of the box and then get out of the way, basically. Now, GitHub primitives is something that you probably need to understand as we jump into GitHub Actions in more detail. And those primitives being the API, webhooks, and authentication. Those are all things that we give to you from Actions for free. Now, there's an analogy that I wanted to mention as well, which is basketball. So if you're familiar with basketball or the NBA, the object of the game is to get the ball into the opponent's hoop. If you're not familiar with basketball, it's kind of like soccer except you use your hands. And here is an example of a basketball court. And back when I was in high school, the sport was actually being played in a way that was not like it's being played today, where you'd have one player, which I want to mention, there's 5 team members on a basketball team. So one player could take the ball and be, I guess, the ball hog or the sort of full court layup expertise. And they would basically take the ball from one end of the court to the other end of the court and score the point without actually engaging other teammates on the court. You might call this like Cowboy Coding, or you usually have like the one senior developer that everybody sort of waits for to make decisions or to get people unstuck. It's not a great way to operate or engage in a code base. Now, in the game of basketball, in the last the last 5 years, there was a book that came out, but also the game changed quite a bit. And they started applying statistics to the game of basketball, very similar to how you would see in baseball, which baseball being the book that went very popular was called Moneyball. They applied that and they called it hooponomics, where you would take every single point on the court and identify what percentage of shots will actually be made at this point on the court. And what they found is the highest rated percentage on the court was 31%, and they call that Area 31 because 31% of the shots actually went in. Now, this has to do with a lot of different things, like most players are right-handed, and based on how close you are to the hoop, it's kind of hard to defend. So, like, based on the arc that you throw in, it's going to go in. It's going to be very hard to, like, defend the jump shot based on that, all those variables. Now, if you know that all the shots, or 31% of the shots, are going to go in at this point on the court, you're going to basically write your plays directed to this point on the court. So this is the 5 people on the basketball court. And here you've got the number 1 who's now passing the ball to number 2 instead of taking it directly in. And number 2 has an opportunity to take the ball to the court, or to the rim. Basically, take the shot. And if that doesn't work out, there's what we call a triangle offense in the game, where you could either choose to pass it to number 3, or you could pass it to number 4 to get yourself out of a sticky situation. Now, this is really good because it helps build the muscle memory of, like, when you get to this point, you know exactly what's going to happen. In programming, what we do is we write tests. We write tests to make sure that if this happens again, or if that happens, we know exactly how to get ourselves out of the situation. Now, we'll move away from basketball and move this directly into our developer workflows. And what I want you to think about through this talk is, like, identifying repetitive tasks. So if we know we're going to do this every single time we do that, why don't we write tests, or why don't we automate ourselves out of this situation of not relying on humans to make those decisions? Those decisions are having been made by automation. Now, continuous integration is something that we apply to GitHub Actions a lot as the idea, the construct. With source control, GitHub being based on Git, the protocol, the version control protocol, that's already a solved problem. Now, with GitHub Actions, you could also run your tests. You can build your deployments, get them prepared for production directly within your GitHub repos based on action runners. You could also deploy staging. You could also deploy it to production. These are all concepts you could sort of build on and add pieces to. Now, one thing that always comes up too as well in the sort of build step is linting. Now, identifying places for you to make those decisions, like if we know we want to have, spaces versus tabs, or we know we're going to have single quotes versus double quotes, it's all decisions you can make in the linting process. Now, this is great because you can also block, when the linting fails or when the test fails, you can block production deploys on failures. One thing that we actually did here at GitHub a couple years ago is we decided to make the decision to no longer use jQuery in the front end on github.com. Now, this was a decision that was made after months and months of discussions. Eventually made the decision, and what they did is actually added some automation to basically decide, okay, if there's any jQuery in this pull request, we're going to basically take that jQuery, compile it into JavaScript, and then suggest for the developer to add the JavaScript to their PR. And this actually became very seamless because not only were we enforcing using JavaScript and no longer using jQuery, we were handing them the code directly in the PR. So that way all they had to do is copy and paste it, put it into their PR, and then they were good to go. So no more discussions of like, oh, well, I didn't touch the jQuery, so I'm just going to skip doing that now. It's at that point where you just say, okay, well, the jQuery is no longer there. JavaScript is here. I'm just going to copy and put it in there. We were able to rewrite the entire code base into JavaScript very quickly. So again, identifying repetitive tasks. You're going to open a pull request. You're going to see if there's jQuery, and then you're going to add the JavaScript instead, even regardless if it was your job to do it or not. Everybody's going to do their job or move the project forward to basically get it to JavaScript ready. Now, with GitHub, very, very passionate about the thing, which is open source. Build on what works. Community is really where GitHub really shines, and the best thing about this is, like with GitHub Actions, there's a lot of examples on the GitHub Marketplace, as well as an open source to encourage you to leverage places to automate your workflow. Now, one that I love using, which is generating release notes at the time of pull request. When I merge my pull requests, I use this tool called Release Drafter. So every time my pull request gets merged, I get generated release notes that I can review and then I can eventually publish. Now, this is an example of the Skyline projects. Skyline is actually something we put together during the winter time. This is a nice little passion project here at GitHub. And what we're doing here is I'm going to show you the releases. And here you can see all my release notes that are generated every time a pull request is merged. I can check to see if it looks good. I can add a tag if I want to update that, and then I can commit those release notes. Now, this is all powered by the power of GitHub Marketplace, but also Release Drafter. So Release Drafter is on the GitHub Marketplace. You can use it in your projects today. And this is an example of my release notes for one of my projects as well. So you can see they're all organized. You can also see, shout out to Dependabot, who had a great release, very involved. I'm able to organize all my Dependabot releases into a separate section, so I can see those separately. And then I can see all the human-generated releases up on top. Now, we talked about all this other opportunity for automation, but we want to talk about some CD opportunity. And identify ways to do cloud deployments and environment management is something that's fairly new in GitHub Actions, but there's definitely something you want to try out. So I mentioned it briefly. Skyline.github.com is a project we put together over the winter break to sort of showcase the skill set, your contributions of the users on GitHub. So here I'm going to enter in my coworker, Michelle, Mich Manners, and we're going to see exactly what their contributions look like in a 3D printed graph. Now, this is using WebGL to generate the images, and essentially that's what it is. Now, this is the project I use for the examples. We put this together for our recent conference, but it's a great example to sort of showcase continuous delivery in GitHub Actions. So in the Skyline project, we can actually go into settings. We can set up different environments as well as secrets as well. So here you can see I've got a staging and I've got a production Skyline environment. I can identify if I need required reviewers, and then you can see I have specific environment secrets as well. And then also shout out, if I wanted to have required reviewers, I can have them here. So if you want to make sure that your deployments don't go out without having a final sign-off by someone on the team, you could also add specifically a user, or you can add an entire team to review. So at least one person from that team needs to review the deployment for staging or production. And here within the GitHub Action visualizer, you can also check out to see at what point in the deploy process are you at. So here we've already deployed the staging. We do have an Azure URL here. So shout out to Azure. And you could actually click through and see exactly what is going on this deployment. Also, you can see I'm actually setting up my reviews. Looks like it's good to go, so I'm going to approve and deploy it. And then now it's been approved, it's going to basically say, okay, let's take it to production. Now, this is all built in YAML, so in order to sort of understand the deploy process and how we set this up in our GitHub Action workflows, all the GitHub Action workflows are YAML files. So here I've got my job, which is called deploy to staging. I am setting a conditional to make sure that only branches that are on the main branch will actually be deployed to staging. So any sort of PRs that are on different branches, they will not be deployed to staging. I'm also going to take the output of the Azure web apps deploy, and I'm going to take that web app URL and apply that to the URL that we just saw before when we click for the production deployment. I can also point to different Azure secrets as well, which I can set up in my GitHub repository to be able to allow the process of deploying to happen. And then for the rest of it, is this simply grabbing the Azure Web Ops deploy, which is an open source repo that I have access to. So you're more than welcome to check that out. But that's the beauty of this, is that it's open source. I can check out the code. I can see what is sort of the interactions that are expected. If I have questions, I can open an issue, or I can talk to the Azure support team if I needed to. Now, another example that I like to talk about too as well is compressing images for the web. This is something I don't ever think about whenever I'm building a site, including my personal site. So this is the GitHub Marketplace. I'm searching for images actions. I'm going to use that for my personal site, which is called BWG Live. I've got tons of images on here, but I just don't ever take the extra effort to compress it because it's my personal site. It's sort of the place I just throw all my work on. And here, I'm going to add this into a YAML, and I'm going to identify anything that's JPEG or PNG or WebP. I'm going to make sure that anything that's going on a pull request that's including those images is going to use the Caliber app's image action. And then I'm going to basically take those and compress them. And that's exactly what's happening here. So you can see quite a number of the images. I had very large images. I wasn't really using the best of its ability. So now I'm reducing up to 60% of at least one of those images down and saving so much space. It's also going to make my bundle somewhat smaller, make sure I'm not overpaying for anything that I'm not actually going to be using. So highly recommend if you have an opportunity to compress your images, or if you want to just take care of that at the time of pull request, you can do that with that. Uploading artifacts is something that is also recent to GitHub Actions, but we've had it for actually quite a while. But it gives us the ability to upload information specific to the build or the deployments. So here in this case, I'm actually running some tests to use Playwright, and Playwright's going to take some screen grabs of different versions of my app in different browsers. So Mozilla, it's going to take a picture in Edge as well as Chrome, and I'm going to upload that directly to my PR's actions. So this artifact will live every time I have a PR that gets opened, or I've had the deployment that gets deployed, and I want to go back in the history of looking to see what was happening at the time. If maybe we want to see some changes, maybe digressed from different visual changes, digressed from different PRs, we can go back in the history and check that out just by uploading it to our actions artifacts. Here you can see where I'm running my Playwright action, as well as you can see where I'm uploading my artifact as well. And it's all through the YAML. This is all directly from the documentation from these projects. So you're more welcome to go to these repos, Microsoft/Playwright-GitHub-Action. It's a Microsoft maintained action, but you're more than welcome to check out the GitHub repository for more details. Now, this comes up a lot in questions about GitHub Actions. Can I run this on my own Azure containers? The answer is yes. You can do self-hosted runners. So here I've got a self-hosted runner directly. You go to the settings of your GitHub repository and add a self-hosted runner, and then it's going to give you the scripts to run in your Azure boxes. So if you have a VM ready to go, this is on my local machine because it's easy to test and take a screenshot. But here, I'm just running the install script to install the action runner, which I also want to point out is open sourced. There's my action runner running, and now I'm ready to go to start running actions directly from the containers that I have access to. Also want to shout out the fact that one of our solution engineers actually did a bunch of content around leveraging Kubernetes to scale your actions up and down. So if you do go the self-hosted running route, check out this GitHub repository. It will give you some examples of how you can use Kubernetes in your own hosted environments. So this is an example of him doing a testing video, being able to run a cluster. So every time you open a pull request, it's going to open up one of these green squares, which is one of the environments that are ready to go. And then whenever the pull request is merged or the deployment has been deployed, it's going to go ahead and spin down basically spin down that environment for you. So you don't have to manage turning on and turning off your own actions as you need them. Also, shout out to Jonico, same person who ran the last example, does have an entire repo called Awesome Runner. So if you want more examples, definitely check out that repository. Now, one thing I love doing is actually using GitHub Action script. It's a nice way for me to sort of test out and prototype interactions with the GitHub webhooks that I have available to me. Now, we use the GitHub Action script to power this entire project called the GitHub Hackathon. And the way we ran this is that we actually had a GitHub repo that took all the submissions for the hackathon as pull requests. Now, the website itself, you would interact with the website, so you didn't actually open the pull request yourself. But the requirement was that you had to log in with GitHub so we could then open the pull requests in the backend on a private repo. And then we leveraged GitHub script to be able to identify if the project was valid. So if it did have valid actions, the the hackathon itself was you submit actions as part of the hackathon, and then folks who submitted the hackathon actions for the hackathon then got a sticker pack and as well as a mug. And with the GitHub Action script, every time a pull request is open, we'd have to decide whether it was good or it could be featured. If it was not good, it would actually just get closed and then close with a comment. And then the submitter would just have to go back and resubmit based on the comment that was provided. But if it was good, it would actually get accepted and they would get the sort of bare minimum prize. If it was featured, it actually got featured on the homepage of the GitHub Action, the GitHub Hackathon website. Now, all we did was just add a label on the pull request, which is what we're doing here in this YAML. I didn't call that out, but the featured or the good were actually labels. And then we ran this 5-line script, which is merge that pull request and then apply the label. Merge that pull request. Because once it was merged, it actually gets added to the JSON list, which I didn't mention as well. But regardless, in order to merge this, we were just merging it just by adding labels. And this was actually made it really simple for us to basically have our phones ready to go every morning. We just go through the open pull requests, add a label to stuff that looked good, close PRs that didn't look good, and then when PRs were closed, they'd actually have regenerated content by actions as well. So this is the final product. These are the actions that got featured. If they got the featured flag, they got featured on the homepage. If they didn't get featured on the homepage, but they still got a prize. All powered by GitHub Action script. So finally, I just want to mention continuous delivery. Automating my storybook deployments, it is continuous delivery. In addition to the Skyline example, that it's like probably more fully functional continuous delivery using Azure. Storybook was another way, but I ended up using Storybook as a solution to deploy to things like GitHub Pages. So because I had an NPM script to basically bundle up my Storybook.js outside of my normal NPM run build to my production deployments, I was able to then use the GitHub Actions Pages deploy to then deploy this specifically separately to a GitHub page. And then the way I'm doing this is by pointing to the bundled output, which is Storybook Static, creating a new branch, which is called Storybook Static, and deploying that. And it worked out perfectly. It gives me the ability to point that and redirect it to a design.opensauce.pizza, which is my project. And it's all powered by GitHub Actions. It gives me the power to basically automate things that I would normally think of in the afterthought, which is I would actually personally never really run the build for my design system unless I really thought about it. But now this is automated every time I open a pull request and merge it. The other thing about the Jake Jarvis action, which I brought up earlier, is with Lighthouse Scores, I never think about running a Lighthouse Score. The only time I think about it is when there's a problem. But now, I don't have to wait until there's a problem. Every time I run a Lighthouse Score in my action logs, or every time I open a pull request in my action logs, there's going to be a Lighthouse Score. And I could then leverage that to then justify whether or not we need to work on building our progressive web app score up, or if our performance went down, we could have that discussion at the time of PR as opposed to after it's already been deployed to production. Now, that kind of that really rounds up all my talk. I appreciate you coming through and watching this on-demand session. You can find if you're interested, I've got tons of GitHub Action tips on my YouTube channel, youtube.com/bdougie. And I really encourage you to check that out, but also try out GitHub Actions. GitHub Marketplace is a great way to start. We also have learning lab courses as well as a couple other talks here at Build that are covering GitHub Actions in great detail. So with that, I am your developer advocate from GitHub, Beyonce advocate on the real, and these are my social handles, and you could reach out to me anytime.